Hey everyone, welcome to week 5 of Building Service Systems. This week we have another exciting week in store for you. We're going to talk about humidity and how you measure it and some of the implications of it, and also sort of how it moves around in buildings. So there's a couple of really important concepts to understand this week. The first one is latent heat, which we'll go over. But basically, latent heat, when you boil anything, well, just let's think of water because it's easiest to sort of wrap your mind around. When you see that steam, right? So that's water vapor. That's when water goes from a liquid to a vapor. It's called steam. So there's actually that steam, while it's pretty hot in terms of its actual temperature, and we've talked about the fact that there's a difference between temperature and heat, if you remember that from 2 weeks ago. And so there's actually a whole bunch of heat or thermal energy in that steam that's it's actually in the molecules of the substance, and that's what's keeping the water as steam. And so we did talk about this in class and in your lesson a couple weeks ago, but remember when steam condenses back into water, um, it releases all of that thermal energy that was actually keeping the molecules as a gas. And so that's a lot of heat. So in 1 pound of water, in order to boil it, you actually have to get it up to its boiling point first, which is 212 degrees, as you should know. So you heat it up to 212 degrees, and then to vaporize, to turn that whole pound of water into steam, you need to add 970 BTUs. So you remember, to heat it up, you take 1 pound of water. If you want to heat it up 1 degree, you should know this, it's 1 BTU, and then another degree is another BTU, and so on. So you heat it up, add 1 BTU per pound per degree, you get it up to 212, and then it actually exists as what's called superheated. It's a superheated liquid. It's not steam yet when it reaches its boiling point. After it reaches its boiling point, you need to add 970 BTUs to vaporize that whole pound. Okay, so that 970 BTUs, remember the first law of thermodynamics, it doesn't go anywhere. It's not destroyed. It has to go somewhere, and where it is actually is in the molecules of that steam. And so then this is my steam, as you can see, obviously. So when that steam, it's existing as a vapor, it's kind of hot, it's kind of dangerous, and has a lot of energy, but not in the temperature itself. It's actually when that steam condenses back into a liquid. So if you take that whole pound of steam, right, the steam, you take that whole pound of steam, and if you could condense the whole thing back into a liquid, you would release that 970 BTUs, right? So that's why you get, your hand gets so hot when you hold your hand over a pot of boiling water, is because that steam actually goes up, condenses on the bottom of your hand, releases the latent heat into your hand, and that's really the most dangerous part of steam. So that's latent heat. The reason I went through that, you'll go through the video, there's some explanations, we'll talk about it in lab. It's really important to understand this because in terms of our building service systems aspect, we're not so much worried about boiling water, but what we do focus on is heating and cooling. So with HVAC, think of a window air conditioner or a central air unit or a heat pump. Those all use latent heat as the primary way it moves heat around. So for an air conditioner, okay, so something that's cooling the inside of a building or a room, if it's a window unit, that, remember, you don't move coolness around per se. You can move cold air around, but in terms of the actual energy transfer, in order to make something cold, you have to remove heat from it. So heat is what moves. So cold air is just warmer air that you pull the heat out of. That's how a refrigerator works, by the way. It's the same process. So it's important you understand the basics of this because this is how anything that is heat pump based or air conditioning, it is all uses latent heat as a primary means to move heat around. So with an air conditioning unit, you're taking heat, you're actually putting it into the refrigerant inside of the air conditioner or the heat pump. So you dump the heat, and what that does is that vaporizes that refrigerant, and that refrigerant goes to the condenser, travels to the condenser, condenses back out. It's called the condenser after all, condenses back out, and it dumps that heat outside. And so that's, if you imagine Okay, so here's a pretty good image of a heat pump. Um, so you can see here, imagine this is your house, right? Or whatever building you're in, and this is the indoor unit, this is the outdoor unit. So this is what's called a split system, pretty typical. Um, and so what you're doing when you're trying to cool, so on the left image you have cooling mode, on the right you have heating mode. So on the left you can see here what's actually happening is this indoor unit, there's coils inside of there if you've ever seen those, A coils. Um, there's coils in here that take heat from around the unit, okay? So you take heat from the air, you dump it into your refrigerant, and then the refrigerant then goes outside through the refrigerant lines, and then it actually condenses. Here's your condenser outside, so it condenses and dumps that heat back out, and it goes back in through the other refrigerant line, and then again, that refrigerant pulls heat, goes outside, dumps heat, goes in, pulls heat, goes outside, dumps heat. So that's what an HVAC system does. That's all based on latent heat transfer, because the latent heat is where that energy is stored in that air. And then what's great about a heat pump is they're reversible. And so in the heating season, you actually do the opposite. You take heat from the outside air, and believe it or not, you can pull enough heat from outside air depending on how cold it is. But remember, back to a couple weeks ago, everything has heat. Okay, everything has heat. The only thing that doesn't have heat, that does no thermal energy, if you remember, is something at absolute zero. So even cold air, modern heat pumps, they can actually work down to like even 10, 5 degrees, the really good ones. So even if it's that cold outside, there's enough heat that if you have the right equipment, you can actually pull enough heat from there outside, go inside, and then in with a heat pump, there's something called a reversing valve that turns the evaporator, which is the thing inside. Okay, this is your evaporator because it evaporates and your condenser's outside. In heating mode, your evaporator, the outside coils actually turn into an evaporator because they're the same coils. You just basically the direction that the refrigerant's flowing through and the temperature. And so, or not the direction, but the temperature, excuse me. And so anyway, this turns into your evaporator outside. So it evaporates, pulls heat from outside, takes that heat, condenses that refrigerant, and it dumps the heat back out, and then that sends it up into your ductwork and so forth. And again, it's a loop. Everything in HVAC is a loop. Pull heat outside, dump it inside. Pull heat outside, dump it inside. And then once it's warm again, you have this little reversing valve that switches the direction of the flow. And so then you have pull heat from the inside, dump it outside, and so on. So it's the same unit, does the same thing, it's just a reverse. Anyway, so that is also part of this week's lesson. I just wanted to go over that because it's just so incredibly important to understand that process. And also it's a little confusing if you're not really familiar with it. And so we'll get into some of the details of latent heat. We'll look at something called latent heat and vaporization, which has 970 BTUs per pound. We'll see some of the sort of ways you can integrate that into sustainable buildings, which we'll really get into next week. And then again, this is something that can be really confusing, so it's really important that you go over this. Humidity, relative humidity. I mean, I'm sure you are familiar with the term humidity. Most people think, oh, it's humid outside. It's, there's a lot of moisture in there, and that's true. But the number you normally hear when people report the humidity is actually the relative humidity. And that's different than the absolute humidity or vapor pressure. So they're very closely related, but there is a distinction, and you're going to need to know that distinction. And so it can be a little bit confusing. So I just want to make sure that you go over this content. And then we'll see how it's applied in HVAC. So that process I just showed you in that image with the heat pump, that's the refrigeration cycle. Again, this is how so much of modern HVAC works. This is how a refrigerator works, the window unit, central air, a heat pump, mini splits, if you're familiar with those. That's all refrigeration cycle. And so you'll get to understand the basics of it. And then finally, we're going to get into psychrometry. So use something called a sling psychrometer, which is this little piece of equipment that you'll use in lab that you literally just swing it around. It's kind of hard to visualize. You just sort of swing it around, and what it does is it tells you something called the wet bulb and the dry bulb, and then you take something called a psychrometric chart, which is a pretty fascinating chart that you will use in lab. And you basically plot the values from the psychrometer on the chart, and it tells you the relative humidity, the dew point, the enthalpy, and a couple other things, but we'll basically stick to those. Okay, and so you definitely watch this video about interpreting psychrometric charts before lab. And then finally, as an application of that, you'll look at a short video of how you can use the psychrometric characteristics of the air to make buildings more comfortable and sort of address efficiency, but in particular, occupant comfort. All right, so it's a really important lesson because we'll kind of lean on this later when we go over HVAC. So make sure you understand it. Make sure you go over this content prior to lab. Remember, we talked about that in lab last week. You're as a hybrid class, lab is really for lab time, and I want to make sure that we have enough time to complete lab. So make sure you do your go over your content, do your any ed puzzles, anything like that that are there before class. So that way you walk into class, you have a really good understanding of what we're doing, and it'll make things work a lot more smoothly in lab. Okay, and of course, if you have any questions in the meantime, let me know. But oh, one last thing I wanted to mention. The lab this week, there's a decent amount of stuff you could do outside of class if you want to. There are, we're going to use that sling psychrometer and sort of do some activities in the building and so forth. So you do need to be there for lab, but you can get a head start in the lab is my point. It's up to you. It doesn't matter to me, but I just want to give you a heads up in case you do want to get a head start. All right, well, that's an introduction to week 5, and I'll see you all in the lab later this week.